A web scene allows you to visualize and understand geographic information in an interactive 3D environment. We could use ArcGIS Pro to author and publish scenes. However, we can also author and view scenes using previously published layers in Scene Viewer, which is a built-in ArcGIS Online application. We can start by creating a new web scene and giving it a title, tags, and summary. This will automatically create a global web scene. Global web scenes render 3D content on a spherical globe, whilst local scenes create a flat space view. Your choice depends on what type of data you're using and what spatial extent your data has. Now we can start to add our 3D data to our scene. By searching for Lyon amongst our layers, we can add bridges and textured buildings. The 3D scene layer packages that we created earlier make it very easy to stream extremely large datasets. For example, the scene layer package containing the textured buildings is over 11 gigabytes in size. We can continue to add to our web scene by adding our point scene layers. And it's worth remembering that if a point layer contains more than 2,000 points, we are required to use a point scene layer in order to display our data in the web scene viewer. Once we're done adding layers, we can drag layers up and down to reorder them, either to make the table of contents look better or to make sure that multiple draped layers are drawn in the correct order. We can also rename the layers to something a little more intuitive. By clicking on the drop-down menu next to the point scene layer, we get the option to configure it. Now by default, point scene layers are shown as 2D dots, but here's where we can get a little more creative. We want a 3D symbol that communicates whether parking is free, paid for, or by permit only, as well as the capacity of each garage or parking area. So to start, we'll choose the main attribute to visualize. In this case, we'll take payment type on the parking garage layer and change the symbol option from 2D to 3D. We can change the colors of the cone symbols, change the size, and configure other cartographic elements such as elevation mode, transparency, and information pop-ups. Now we have a symbol that uses color to communicate payment type, we can add a label that tells people what the capacity of the parking garage is. Switching on the label slider lets us choose a field to use as the label, and the Improve Perspective option will help us to better visualize these labels. Once we're done, we can save our web scene and visualize our parking layer with 3D colored cones that tell us payment type, labels telling us capacity, and information pop-ups that tell us more about each parking garage. In the same way, we can configure the tree point scene layer. Choosing species as the visualization attribute and 3D as the symbol type gives us the option of either using realistic vegetation symbols or thematic vegetation symbols. We'll choose realistic tree symbols to match the styling of our buildings and base map layers. This powerful visualization lets us create an interesting and compelling visualization, which helps us to better get our message across. Now that we've generated our web scene, we can capture some slides. Slides give us the ability to determine placeholders or bookmarks that are important to our audience, for example, highlighting important viewpoints that we want people to visit. They contain a view position, a thumbnail, and a name. They also maintain layer state so that we can make sure the right information is presented in the right way at the right place. And finally, we can save our web scene. Here we can give it a name, a summary, tag it with relevant metadata tags, and choose with whom we want to share it, whether it's a private scene, one for sharing within groups within our organization, or a web scene for public consumption.